Ever sent a text and just wondered how it gets to your friend in a split second? It feels like magic, doesn't it? Well, it's not magic. It's all thanks to computer networks. And today, we're going to break down exactly how they work. So, let's get started. Think about it. Every single day, we're doing stuff like this. Chatting, sending emails, checking our bank accounts online, and we don't even think twice. But this stuff doesn't just happen. It's all powered by this incredible, invisible infrastructure.
And yep, you guessed it, the answer is computer networks. These are the systems connecting everything from your phone to massive servers across the globe. They are quite literally the backbone of our modern digital world.
Okay, so let's get into the good stuff. We're going to break it all down. Every single network, whether it's big or small, is built from 3 core components. But what are they?
Let's really look at what makes all this digital communication possible. What are the essential building blocks?
And here they are. Every single computer network, from the Wi-Fi in your house to the entire global internet, is built from just these 3 things: hardware, software, and a medium. Let's dig into each one.
First up, hardware. This is all the physical stuff, the gear you can actually see and touch. We're talking about your computer, your phone, all the cables, and that blinking router sitting in the corner of your room.
Next up, we have software. Now, if the hardware is the body of the network, then the software is definitely the brain. These are all the programs and these special sets of rules, we call them protocols, that tell all that physical hardware exactly what to do.
And that brings us to our third component, the medium. This is the actual pathway that the data travels on. It could be something physical, like an Ethernet cable plugged into your computer, or it could be totally invisible, like the Wi-Fi signals carrying data right through the air.
Okay, now listen up, because this is a huge exam tip. A really common mistake is that people only list hardware and software. You have to remember the medium. Without a path for the data to travel, you just don't have a network. You need all 3, no exceptions.
All right, let's take a closer look now at the brains of this whole operation, the network software.
You see, network software isn't just one single thing. It's actually made of 2 very different types that have to work together perfectly for you to send even a single message. So on one hand, you've got the network operating system, or NOS for short. Think of this as the network's manager. It's running the show behind the scenes. And on the other hand, you have the application software. This is the stuff you actually use every day: your web browser, your chat apps, your games.
And this is the crucial point, right? A network needs both of these to work. You just can't have one without the other. The network operating system manages everything, and the application software is what lets you, the user, actually do things on the network. So now that we've covered the brains, let's talk about the body, the physical building blocks of the network, the hardware.
All of these different physical devices you see here, they all come together to build the network's infrastructure. And each one has a very specific and important job to do.
You'll obviously recognize your computer and the modem. That's your gateway to the internet. But inside the network, you've got devices like a router, which acts like a traffic director between different networks. Then a switch helps devices on the same local network talk to each other. They're basically the traffic cops of the digital world, making sure every bit of data gets to the right place. Okay, we have covered a lot of ground, so let's wrap this up with a nice, clean, exam-ready summary to put all these pieces together. You can really think of it like a simple formula. You take your hardware, you add the software, and remember, that's both the operating system and the apps, and then you connect it all with the medium. What do you get? Global networking. It's that simple.
So let's lock in the most important takeaway here. For any network to work, you absolutely need 3 things: the physical gear, which is the hardware, the brains to control it all, the software, and a path for the information to travel on, the medium.
And to make sure you never ever forget this for an exam, I've got a super simple memory trick for you. Just remember these 3 letters, HSM.
So what does HSM stand for? It's simple, right? H for hardware, S for software, and M for medium. Remember, HSM, and you will always have the 3 core components of any network. Easy peasy. And there you have it, the 3 core components that build our entire digital world. So now that you know the foundations, what are you most curious about? Is it the specific hardware that directs all the traffic, the complex software that runs everything, or the invisible medium that carries all that data? Let that curiosity guide what you learn next. Thanks for tuning in.
You know how we always think of the internet as this magical, invisible cloud? Well, what if I told you it's actually a real physical journey? Yeah, every single time you click something, you're sending a tiny packet of data on an incredible trip across the globe. In this explainer, we're going to follow that journey step by step. I mean, seriously, how does that even work? You click a link and poof, a video from a whole other continent just starts playing. It's not magic, though. It's more like a high-speed road trip for your data. And today, we're going to map it all out. Okay, so this diagram right here, this is our map for today. We're going to follow the data's path all the way from that big internet cloud on the left through each one of these devices right to your computer. And hey, a little heads up, being able to draw and explain this exact flow is a classic exam question, so let's make sure you know it inside and out. So our little data packet has left the internet and it's heading towards your house. But to get inside, it has to get past some very important gatekeepers. Let's meet the first one. First stop is the modem, and a great way to remember its job is to think of it as the translator. Why? Well, the signal that comes to your house from the internet, through phone lines or cables, is an analog signal, kind of like a smooth wave. But your computer only understands digital signals, which are clear on and off pulses, like a light switch. The modem's whole job is to translate between these two different languages. And you know, the name modem actually tells you exactly what it does. It's short for modulator, demodulator. It modulates your computer's digital signal into an analog one to send it out, and it demodulates the incoming analog signal back into digital for your computer. Without this translation, there's just no conversation. It's the absolute essential first step. All right, once the data is translated, it immediately hits the router, which is basically the brain of your home network. Think of it like a traffic controller at a busy intersection. It looks at the data packet, figures out exactly where it needs to go, and sends it down the most efficient path. And this thing is a real multitasker. First, it connects all your devices together to create your own little home network. Second, it gives every single device a unique address called an IP address. It's like a specific house number for your laptop or phone on your network street. That's how it knows where to send the data. It also manages all the traffic to prevent jams and even acts as a basic security guard, blocking suspicious things from getting into your network. Now, once the router decides where the data goes, how does it actually get there if you have a bunch of devices plugged in? Well, in the old days, we used a hub. And the hub was kind of like that person who shouts a secret across a crowded room. Super inefficient, and everyone hears it. Today, we use a switch, which is way smarter. It's the whisper. And this slide shows that difference perfectly. The hub on the left is the shouter. It just blasts the data out to every single connected device. It's messy and not very secure. But the switch on the right is the whisper. It's smart. It knows the unique physical address of each device. We call that a MAC address. And it sends data only to the specific device that needs it. This makes your network way faster and way more secure. Okay, but we're not all plugged in with cables, are we? For our phones and laptops, the data needs to make one more stop. After the router or switch, it goes to something called a wireless access point, or WAP. You probably just know it by its other name, Wi-Fi. A WAP does one simple but really important thing. It takes the internet signal from a physical cable and converts it into wireless radio waves. That's Wi-Fi. Now, here's a huge exam tip. In most homes, the box you call your router actually has a router, a switch, and a wireless access point, all built into one single device. But it's so important to remember for your exams that they are 3 separate functions. So we've met all the smart devices, but what actually connects them all together? We need to talk about the physical pathways, the actual roads and highways that carry our data. On the left, you see the good old Ethernet cable. You've definitely seen these in your school's computer lab, right? Connecting PCs to the network. And on the right, well, that's the future. Fiber optic cable. Instead of electricity, it uses pulses of light traveling through tiny strands of glass. It's incredibly fast, and it's what forms the main superhighway system of the entire global internet. This brings us to a really fundamental trade-off, and trust me, you'll definitely see questions about this. It's wired versus wireless. A wired connection gives you stability, amazing speed, and better security. It's perfect for a gaming PC. Wireless, on the other hand, gives you the freedom and convenience to move around with your laptop. It's always a choice between raw performance and pure convenience. So think about it. If you're a professional gamer who needs every single millisecond of speed, what do you choose? A wire, right? But if you're just browsing on the sofa, what's the better option? Wi-Fi, of course. Understanding that trade-off is absolutely key. Okay, we've done it. We have completed our journey from that big internet cloud all the way to our screens. So let's quickly recap the most important points to really lock this in for your exams.
So our field study is officially complete. We've successfully mapped the whole network, identifying the modem, the router, the switch, the access point, and the physical cables. Now, let's just boil this all down into the key revision points.
If you remember nothing else from today, please remember these 5 points. This is your ultimate revision list. Number 1, modem translates. 2, router directs. 3, switch distributes. 4, access point makes it wireless. And 5, cables connect it all physically. Simple as that. Now for a direct exam tip, listen closely. A very, very common question asks you to draw and label that first flowchart we looked at. They want you to explain the job of each device in order. If you can do that, you are set for some serious marks. And to make absolutely sure you never forget that order, here's a little memory trick. Just remember the sentence, "My router sends all connections." That gives you modem, router, switch, access point, and cables in the exact right order. So now you know your internet's secret journey. How cool is that? All right, today we're going to dive into a small but super important device that basically keeps our digital world connected, the network repeater. You've definitely used one, or at least benefited from one, probably without even knowing it. So let's find out how these things actually work. So let's start with a problem that I'm sure every single one of us has faced. You know the one. You're watching a video, everything's fine, but then you walk into another room and loading, buffering. Ugh, why does your connection just die like that? Well, it's not random, I promise. There's a very real technical reason behind it. And that brings us right to the heart of the issue, the signal strength problem. You see, every kind of signal, whether it's Wi-Fi buzzing through the air or data zipping through a cable, runs into the same basic challenge. Look at this. A signal always starts out really strong and clear, right? Like that wave on the left. But the farther it travels, the weaker and more jumbled it gets. There's a technical term for this. It's called attenuation. And that's exactly why your Wi-Fi gets weaker the further you move from your router. The signal is basically just running out of steam. So if signals just get weaker on their own, how on earth do we send information across a big office or a whole building, let alone across the country? Well, our tired little signal needs a hero. And that hero is called the repeater. The solution is actually pretty clever. You just place a repeater right in the middle of the signal's path. Think of it like a pit stop in a race, or a relay station for the data. It gives the signal the fresh boost it needs to finish the journey strong. Okay, pay close attention here, because this is the official definition you'll need for your exams. A network repeater is a device that regenerates or replicates a signal. Now, lock onto that word regenerates. It's so important. It doesn't just make the signal louder, it rebuilds it from the ground up. Honestly, if you remember that one word, you're halfway there. So we know what a repeater is, but how does it actually perform this magic trick of bringing a weak signal back to life? Let's break down the process step by step. It's actually a really simple 3-step process. First, it catches the weak signal. Second, it does its main job, that regeneration we just talked about. And third, it sends the brand new, powerful signal on its way. Let's take a closer look at each of these steps. Okay, step 1 is input. The repeater is placed strategically to grab the signal just before it gets too weak to even be recognized. So it receives this tired, distorted signal that's traveled a long way from wherever it started. Now for the most important part, step 2. The process. And there's that magic keyword again, regenerates. A repeater doesn't just, turn up the volume. It looks at that messy, weak signal and it rebuilds it, piece by piece, back to how it was supposed to be, perfect and strong. I really love this quote because it just nails the concept. It doesn't just make it louder, it reconstructs the signal. Think about it. If you just make a noisy, garbled signal louder, you're just yelling the mistakes. The repeater is way smarter than that. It rebuilds it completely. Here's a perfect way to think about it. Just amplifying a signal is like trying to shout a mumbled message from across a field. Yeah, it gets louder, but it's still mumbled and hard to understand. But regenerating? That's like a relay race. The first runner is exhausted, but they pass the baton, the message, to a fresh runner. That new runner doesn't just keep jogging tiredly. They take the message and sprint off at full speed, delivering it perfectly. The repeater? It's that fresh runner in the race. And that brings us to the final step, number 3, output. Once the signal is perfect and back to full power, the repeater transmits it, sending it forward on the next leg of its journey. The result is a clean, powerful signal ready to travel another long distance. So let's put all of those pieces together and just quickly look at the signal's entire journey from start to finish. So to sum it all up, a weak, fading signal comes in one side of the repeater. Inside that little box, the magic of regeneration happens. And then, out the other side comes a strong, clean signal, good as new and ready to keep going. It's a simple but absolutely essential process for our networks. Okay, now that you totally get the concept, let's zero in on the key takeaways. These are the points you absolutely want to have locked in for your exams. So here are the 4 big things to remember. First, the definition, it's all about regeneration. Second, the problem it solves, which is that signal degradation or attenuation over long distances. Third, its key function is to regenerate, not just amplify. And finally, that simple 3-step process: input, process, and output. Okay, listen up. Here is a pro tip, a common mistake you need to avoid. So many students just say a repeater boosts the signal. And I mean, that's not wrong, but it's not the whole story. To get full marks and really show you know your stuff, you have to use the keyword regenerates. That's the word that will make your teacher nod and give you that top grade. So to wrap this all up, here's a classic exam question you might see. To get all 3 marks, you just draw that simple diagram we looked at, a weak signal coming in, a box in the middle labeled repeater, and a strong signal going out. The crucial detail? Inside that box, you write the word regeneration, and that is how a network repeater works. Simple as that. Thanks for watching.
Have you ever walked into your school's computer lab, seen all those PCs lined up, and wondered, how do they all talk to each other? How do they all get online at the same time? Well, the secret is a simple little box called a network hub. And trust me, if you're gearing up for exams, you absolutely need to know what this is. So let's dive right in.
I mean, really think about it for a second. It's not magic, right? There's a piece of hardware that acts like a central meeting point for every single computer in that room. And in the early days of networking, that central point was almost always the humble and, honestly, not so smart network hub.
So what exactly is this thing? Let's break it down and get a super clear definition that'll be perfect for you to use in your exams.
Okay, take a look. This right here is a network hub. Doesn't look like much, does it? It's really just a simple box with a bunch of ports. The easiest way to think about it is like a power strip, but for network cables. Each one of those ports is a spot to plug in a computer. All right, now this is the key definition for your exam, so you might want to jot this down. A network hub is a connectivity device that links computers together into what we call a single network segment. Its job is really simple: create a shared space where all the computers can communicate. Now that we know what a hub is, let's talk about how it organizes the computers it's connected to. In the world of networking, we call this the topology, which is just a fancy word for the layout. So what does a network built with a hub actually look like? This image shows it perfectly. A hub creates something called a star topology. Just picture the hub as the bright center of a star, and each computer is like one of the points. Every single connection radiates out from that central hub. It's a really neat and organized way to set things up. Okay, so we know what it is, and we know what the layout looks like. But now we get to the most important question. How does a hub actually share information? This part is absolutely crucial to understand. So here's where things get interesting. When one computer wants to send a message to another, it sends that data to the hub first. The hub gets the message, and then what does it do? Well, this is where the hub's simple and, let's be honest, kind of clumsy nature really shows. See, a hub isn't intelligent at all. It has no idea where that message is actually supposed to go. So it does the only thing it knows how to do. It shouts. Imagine you're in a quiet library, and you want to whisper a secret to your friend across the room. A hub would just stand in the middle and yell that secret at the top of its lungs so everyone in the library hears it. It broadcasts every single message to every single computer. This creates a huge digital traffic jam and what's known as a collision domain. Basically, if 2 computers try to shout at once, their messages just crash into each other and get all scrambled up.
So, with that whole shouting method in mind, I think it's time for the hub's report card. Let's see where it gets top marks and, well, where there's definitely some room for improvement. You know, for a long time, the hub got an A for effort. Its biggest advantages were that it was super simple and really cheap. It was so easy to set up, you literally just plugged everything in, which made it perfect for small, basic networks where you didn't have a big budget.
But that shouting method, it's a massive downside. With every message being blasted to every computer, the network gets clogged up and slows right down to a crawl. And that's exactly why the hub is pretty much a relic of the past now. It's been replaced by a much smarter device called a switch, which acts more like a mail carrier, delivering each message only to the person it's actually addressed to.
Okay, deep breath. We've covered a lot, but now it's time for the lightning round. This is your exam cram session, where we're going to lock in all the key facts about the hub.
Are you ready? Let's do this. Here are the must-know, absolutely essential things to remember about the network hub.
This right here is your cheat sheet. Let's break it down, nice and fast. What is it? A multi-port device to connect computers. What's the layout? A star topology. What are the pros? It's simple, it's cheap, and it's easy to use. And what's its status today? It's old news, totally replaced by the much smarter switch. Got it? Awesome!
And hey, if you need a quick way to remember its main job for the exam, just think of the letters in HUB. A helpful, united broadcaster. That word, broadcaster, is the key. It tells you everything you need to know. It sends every message to everyone.
So I'll leave you with the question to think about. If the hub is a shouter, what makes a modern switch a whisperer? How does a switch know exactly where to send each message without telling the whole network? Well, that's the next step in your networking adventure. Thanks for tuning in, and happy studying.
You ever been in your school's computer lab and just wondered, how does this all work? I mean, you can grab a file from the main server, you can send a document to the printer from pretty much any computer. It's all so seamless, almost like magic. Well, today, we're going to pull back the curtain and figure out what's really going on.
Yeah, seriously, how does it work? If every single computer was just shouting information at every other computer all at once, it would be total chaos, right? A digital traffic jam. But it isn't. There's like an invisible traffic cop directing everything, making sure every little piece of information gets exactly where it needs to go and fast.
And that invisible traffic cop? Well, that's what we're here to talk about. The hero of our story is called a network switch. This is the amazing little device that takes all that potential chaos and turns it into a super orderly, super efficient network. So let's get to know it. Okay, this right here, this is your core definition, the one you'll want to have for your exams. A network switch is a physical piece of hardware, a box with a bunch of ports that you plug cables into, and its whole job, its entire reason for being, is to act as a central point that connects devices like computers, printers, and servers so they can all talk to each other. And this picture shows that main job perfectly. You can see the switch sitting right there in the middle, kind of like a central station connecting all the different computers. The goal is simple, but it's really powerful. Let all these separate machines share information. Without that switch, they'd just be lonely little islands. But with it, they become a connected community.
So, we know what a switch is. But the really cool part, the clever part, is how it works. This is what makes a switch so different from older, dumber devices. To get our heads around it, let's think of it like a really smart postman.
Okay, so in most networks, you've got a file server. Just think of that as the main library, right? It's where all the important shared files live. The switch sits right in between this library and all the computers that want to check out a book or, a file. It's the coordinator, managing every single request.
And this is the absolute key. This is what makes a switch so smart. It's all about intelligent delivery. So when the server sends out a piece of info for, let's say, computer B, the switch doesn't just blast it out to everyone. No way. It actually reads the destination address on that data and sends it only to computer B. As you can see, computer A and computer C, they don't get the message. It's a private, direct delivery.
So let's just break that down into 4 simple steps. Step 1, the server sends out the data. Step 2, the switch grabs it and reads the specific address. Think of it like a house number for each computer. Step 3, it creates a temporary, private little highway directly to that one computer. And boom, step 4, the data gets delivered. It's clean, it's private, and it's really fast.
Now, to really truly appreciate how brilliant the switch is, we have to compare it to its older, much less intelligent cousin, the hub. And listen up, because this comparison is a classic exam question, so you're going to want to know this. It really all comes down to why being smart is also being fast. Just look at the difference here. On the left, you've got the hub. A hub is like a town crier. It gets a message and just shouts it out to everybody in the town square all at once. It just creates this huge mess of confused traffic and everything grinds to a halt. But on the right, you've got our switch, the smart postman.
It creates a nice, clean, direct path for every single letter, making the whole system way, way faster.
And this table? This sums it up perfectly for your notes. A hub broadcasts to all. That means congested traffic and slow speeds. A switch sends directly to one. That means efficient, private traffic and awesome speeds. The biggest takeaway? A switch is intelligent, and a hub is, well, not. And that's exactly why pretty much all modern networks use switches.
Okay, deep breath. We've covered the what, the how, and the why. So now let's boil it all down to the absolute most important points you need to lock in your brain for that A+. This is your final revision guide.
Let's run through these key points one more time. First, remember it's a physical device, a piece of hardware. Its job is to join computers together so they can share info. Its role is to be that smart coordinator between the server and the PCs. Its method is what makes it special. It routes data to one selected computer. And the big benefit? It is so much faster than an old hub. Memorize these 5 facts.
And hey, to make sure this all sticks, here's a super simple memory trick for you. Just remember the 3 S's. Switches are smart, sending specifically. That little phrase will help you remember the most important thing about a switch, its smart, specific way of getting the job done.
So we figured out how one little switch can run an efficient network in your school. But that brings up a much bigger, wilder question, doesn't it? How do millions, maybe even billions of these things all work together to create the entire internet? It's just a massive network of networks, all built on these same basic ideas of smart direct delivery that we talked about today. Pretty cool to think about, right? And it all starts with this one simple device.
Hey everyone, and welcome. So picture a massive bridge, like the Golden Gate Bridge, right? It connects 2 huge pieces of land, so cars can zip back and forth. Simple enough. But what if I told you we have bridges inside our computer networks? You can't see them, but they're doing pretty much the same job. So what are these things, and how on earth do they work? Well, let's dive in and find out.
So let's bring this closer to home. Think about your school, right? You've got the computer lab packed with PCs. Then you've got the library with its own set of computers. They're totally separate networks. And yet, somehow, you can be in the lab and pull up a file that's stored on a library computer. It feels like magic. But how does that actually happen?
Well, the secret behind that school magic is this little hero right here, a network bridge. And yeah, the name pretty much gives it away. It's a physical piece of hardware, a device that literally acts as a bridge, connecting 2 different networks so they can start talking to each other.
Okay, so let's dig in. What exactly is a network bridge? This is the part where we connect our digital worlds. All right, get your notebooks ready, because this is the official need-to-know definition for your exams. A network bridge is a hardware device that's used to connect 2 separate computer networks. And here's the cool part. It allows them to communicate as if they were just one big network. It's like the digital glue that holds everything together.
Okay, next up, the one golden rule. This is probably the most important thing you need to remember about bridges, especially for your tests. And here it is. This is super important. A bridge connects 2 networks that have similar protocols. Now, what in the world is a protocol? Easy. Just think of it like a language. It's the set of rules computers use to talk to each other.
So the rule is simple. Bridges only connect networks that speak the same language. You can't use a bridge to connect a network that's speaking English to one that's speaking German. It just wouldn't work. They have to be on the same page, using similar rules to communicate.
All right, so now we know what a bridge connects, but how does it do it? It's not just a dumb pipe letting everything through. Nope. Think of the bridge as a super smart filter or a traffic cop. Let's break down how it works, step by step.
This diagram pretty much says it all. The bridge is like a gatekeeper. A piece of data, we call it a packet, comes up to the bridge. The bridge looks at it and has to make a choice. Do I let you pass to the other side, or do I stop you right here? Let's break down exactly how a bridge filters traffic. It happens in 3 super simple steps. Step 1, inspect. A data packet shows up at the bridge. Step 2, decide. The bridge takes a peek inside the packet and checks the destination address. It's basically asking, hey, where are you trying to go? And finally, step 3, action. Based on that address, the bridge makes its move. So how does it make that final choice? It's really simple. If the destination address is on the other side of the bridge, on the other network, well then it forwards the packet. Makes sense, right? But what if the destination is on the same network the packet came from? Then there's no need to cross the bridge at all.
So the bridge just discards it. It drops the packet. This is super smart because it keeps unnecessary traffic from clogging up the other network. It's all about being efficient.
Okay, let's wrap this up with your exam quick recap. These are the key revision points you'll want to remember.
All right, let's review the key takeaways for your exam. Think of this as the ultimate cheat sheet. Well, not a cheat sheet, but you know what I mean. The perfect revision note. If you know this stuff, you're golden.
So let's hit the top 3 exam points you absolutely have to know. Number 1, its identity. What is it? It's a network connectivity device. Number 2, its constraint. What's its main rule? It connects 2 networks with similar protocols. And number 3, its action. What does it do? It inspects signals and decides to either forward or discard them. Easy, right?
And hey, if you want a super simple way to remember all that, I've got a memory trick for you. Just remember the letters BSF. A bridge connects similar networks by filtering traffic. BSF. Got it? That little trick could be a lifesaver on exam day.
Okay, so to wrap up, here's a final question for you. We've learned that a bridge is perfect for connecting similar networks, right? Networks that speak the same language. But what about connecting networks that are completely different? Like, how does your school network connect to the entire global internet? A bridge can't do that. So what device can? That's a great question to think about for next time.
Okay, picture this. You're at home streaming your favorite show. At the same time, your sibling is in the middle of a huge online game, and maybe your parents are on a video call in the other room. How in the world does all that work so smoothly, all on just one internet connection? Well, the answer is a little device we're going to talk all about today, the network router. Seriously, have you ever stopped to think about it? How do all those different gadgets in your house, your phone, your laptop, the smart TV, maybe even a gaming console, get online all at once? It kind of feels like magic, right? But it's not magic. It's just some really, really clever technology. All right, so let's meet the hero of this story. The answer to that question is usually a small box, probably sitting in a corner of your living room, just quietly blinking away. This is it, the network router. This little guy is the unsung hero that manages literally everything you do online. So let's get right down to it. What is a network router? Now, this is a really fundamental concept. And you guessed it, a super common exam question. So let's break it down nice and simple. Okay, so at its most basic level, a router's main job is to join different networks together. You can see it here. It connects your personal wireless network, that's all your stuff, like your phone and laptop, to the wired network that comes into your house from the internet company. It's the middleman that connects them all. Now, to make this whole idea even easier to get your head around, let's use a great analogy. Let's think of the router as a kind of bridge. So, just like a real bridge connects 2 separate islands so that cars can drive between them, a router connects your own little home network to the giant, massive network we call the internet. It creates that path for all your data traffic, your videos, your games, your social media, to flow back and forth without a problem. But here's where it gets really cool. It's not just a simple, empty bridge. A router is more like a smart bridge, one with a checkpoint on it. It doesn't just let anything pass. It actually looks at these little chunks of data, which we call packets, to make sure they're going to the right place before it forwards them on their way. And that, of course, brings up a fantastic question. If this one little router is handling data for your TV, your phone, and your computer all at once, how does it know which data packet goes where? How does it sort all that information out without getting everything mixed up? Well, the answer is hidden in a really clever address system that the entire internet is built on. And that system is called the Internet Protocol Address, or as you've probably heard, an IP address. Now listen up, because this is a huge one for your exams. An IP address is a totally unique address that's given to every single device connected to a network. The best way to think about it is like the postal address for your house. It makes sure the mail gets to the right person. So here's the key takeaway. The router acts like a super fast, super smart mailman. Every little data pocket is like a letter, and on that letter is the IP address of where it needs to go. The router reads that address and makes sure that letter gets delivered to the correct house, whether that's your gaming console, your laptop, or your smart TV. But wait, there's more. There is one other key function that makes a router truly special. It doesn't just connect networks and read addresses. It's also incredibly smart about how it sends your data out into the world. You see, a router is an intelligent device. When you search for something online, your request has to travel across the vast internet. And there isn't just one road to get there. There are millions of possible paths. The router's job is to act like a GPS for your data. It instantly finds the best, fastest, most efficient path to avoid any digital traffic jams. Okay, so we've covered all the core concepts of what a router is and what it does. Now let's switch gears a bit and really focus on an exam takedown to make sure you remember all the important stuff. Let's recap it all with this simple mind map. There are 4 key ideas you need to have locked in. Number 1, it's a connectivity device that joins networks. 2, it acts like a bridge, inspecting and forwarding data. 3, it uses IP addresses to know where everything needs to go. And 4, it's intelligent because it finds the best path for data. So how is this going to look on an actual exam paper? Well, you might get a simple question like, what is a network router? Or maybe something a bit more detailed like, list and explain 2 key functions of a router. And a very common one is to explain the role of an IP address. So you've got to be ready to talk about it being a unique address for every device. And to help you remember all this when you're under pressure in an exam, here is a super simple memory trick. Just think of the word trip. A router is your data's trip manager. T is for traffic director, R is for reads IP addresses, and P is for pathfinder. Trip. Easy as that. So the next time you're online, just glance over at that little box. Now that you know how it's connecting, directing, and intelligently managing literally everything, can you see how that humble router is truly one of the most important and hardworking devices in our entire connected world?